think I found it. There's the Windows record unit thing. Okay. So good morning. Good morning, Trinity Classical Academy. This is an impromptu snow day lesson. I'll try to keep it sweet and to the point. If you find that I'm dragging a little bit slowly, you feel free to speed up the video. You can watch it at 1.5 times speed or 2 times speed, but hey, be responsible, okay? Make sure you're following along really well. I don't want you to just speed through this thing so you can say you're done. You have to learn it so that you know it. So open your book. I'm gonna first lay a couple of ground rules. First of all, I'm gonna sometimes do this with the red pen, and we're gonna do pause the video. When you see that, that means pause the video and work on a problem, and then when you're done, you may resume the video. Otherwise, I'm just gonna be showing you the lesson and we're gonna be walking through. So open your book to page 220. I'm not gonna do Roman numerals this time, so you're welcome. 220, open your books. We've found how to write equivalent equations. Equations have an equal sign. That makes them an equation. We're going to talk about inequalities, which is an expression that shows that some things are not equal. There are many different kinds of inequalities, right? There's less than or equal to, not equal. We're pretty much going to just ignore that one for this one, for the purpose of this lesson. Just two things are not equal. And then of course there's greater than or equal to, or straight up just greater than. Nice and symmetrical, right? My computer's being really slow right now, so I hope this is recording okay. There it goes. Okay. Yep, we're erasing. Erase. There we go. All right. So we've always done things on this equal sign, but what if two things are not equal and we want to make sure that they're still not equal? You might be inclined to think, oh, this is going to be exactly the same. And for most things, you might be right. But let's do a quick warm-up. Ignoring the not equal to sign, let's suppose that I have the numbers 3 and the number 3 and the number 5. I want you to go ahead and, which one is greater? If you were going to draw a symbol with your finger, which one is the greater than? You would write this, right? 3 is less than 5. 5 is greater than 3. You can write it like that. But the big part of this caret should be pointing at the 5, because 5 is bigger. Look at the little picture at the bottom of page 221. You see the blue math note? That's just a reminder, okay, greater than is the bigger part. Points to the bigger part, and less than points to the smaller part, right? Hopefully that's pretty basic review stuff. Actually, there we go. Okay. What about this one? We'll go a little bit trickier. Let's say we have -2 and 4. Which one is greater? 4 is greater. 4 is greater because on a number line, if I have 0 over here, 4 is going to live over here, -2 is going to live over there, right? Because whichever number is further to the right on a number line is always greater. As I go to the right, the numbers get greater. As I go to the left, the numbers get smaller. Okay, so let's try another one. I think we're done. Just remember, well, we'll do another one. We'll do another one. I'm going to erase this right here. We'll do another one. We'll do -0.5, and we'll do -3. All right, which one is greater? Think about it. Pause the video if you need to. Pause the video if you need to. Okay, which one's greater? It's actually this one. I hope you got it right, because over here is going to be -3, and over here is going to be -0.5. Which one's farther to, that's the wrong decimal point. Which one is farther to the right? This one is farther to the right. You can't see that, can you? When I wave my mouse around. That one's farther to the right, this way, on the number line. So it is greater. We're going to play with that a little bit more. It's going to start getting in your head, and it's going to be trippy. I guess undo just isn't going to do it this time. All right. So looking at page 220, they start with a solution. They're talking about a solution set. So we had talked about the equal sign, but if we have an inequality, we're going to have one that's greater. So we're going to have something that's greater than something else. It's going to be heavier on this scale, right? It's going to be heavier. And so if we say, if you look at this, the thing that they say on what was it? The expression. Consider the inequality x plus 3 is greater than 4. So they say, okay, well, we can try guess and check. Ignore method number 1. Method number 1 is, I mean, method number 1 can work. If you think about it, you're like, well, let's try substituting in something for x. Let's say x equals 0. Okay, that doesn't work. And then they keep guessing and checking, which can work sometimes for some crazy problem solving if you're a mathlete. But the inequality x plus 3 is greater than 4. So if this is true, look at page 221 now. Page 221, that's a terrible one. I'm still trying to be European with my ones, even on the touch screen. So if x plus 3 is greater than 4, what does it represent? We have something that is x. And then we have x plus 3. And over here we just have 4. We have 4 little pounds signs over there. We know that this is heavier. However much x weighs, we're not sure exactly, but we know that x and 3 ones is definitely greater than 4 ones. So what can we do to really narrow down? We want to try and hone in on just x. Same as we solve an equation with the inequality, we want to make sure that we isolate the variable by itself with a coefficient of positive 1. So we know, okay, so if x plus 3 is greater than 4, what is just 1x? What can we know for sure about just 1x? We don't know what it's equal to, but we know we could easily see that if I take away 3 from both sides, I'm going to have x on one side, I'm going to have 1 on another. I can subtract 3 from both sides, do the same thing to both sides, subtract 3, and I'm going to end up with another inequality that is an equivalent inequality. That's a vocab word. Those inequalities are the same. So I have this inequality right here, x plus 3 is greater than 4, is the same as x is greater than 1. And we can see that visually represented right here. There we go. Just like on page 221, right? Now, if you're going to graph these on a number line, we've already done this in the introductory homework way at the start of chapter 4. But let's turn the page to page 222. This is the page you should be on. 222. In order to graph a solution set, so suppose we have, I'm gonna use the solution set that we had last time where x was greater than 1. We're going to have a 0 here. Let's graph 1 right here. We know that x is greater than 1. So we're going to draw a circle right above the number 1. And we're going to say x can be any of these. We don't know how much x is, but we know it's not 1, but it's something greater than 1. Anything greater than 1 works. 2 could work. 2 is part of the solution set. What else is part of the solution set? Well, 3. What else? Certainly not negative 1. That's not part of our solution set. However, 1.2 is part of the solution set. I could even zoom in really close and get down to here and say 1.0000, I don't know, 3. That's part of the solution set because this is greater than 1, not by much, but ever so slightly greater than 1. So that's part of this solution set. Anything on the number line that is to the right of the number 1 is part of the solution set of x is greater than 1. Now, let's suppose we wanted the solution set to include 1. If it says x then is greater than or equal to, what we're going to do is we're going to fill in this circle. Again, this should be review. That should be a solid dot, not an empty circle when you do that. Make sense? That's the solution set. So we're trying to define what is in a solution set. So looking now to page 223. Hey, don't look outside at the snow. Look at page 223. I know, yeah, that's right, I'm talking to you. I saw you. I didn't, but that's okay. Example 8, solve and graph the solution sets of algebraic inequalities with variables on the same side using addition and subtraction. Okay. So it says solve the inequality and graph the solution set. So in number A, they have 0.1y plus 7 plus 0.9y is less than 9. They combine like terms. So we have 1/10 of a y and 9/10 of a y. They just combine that into 1y. And then they subtract 7 from both sides. They get y is less than 2. Hopefully you're able to listen without me doing stuff on the screen. So hopefully you listened. So this time the variable is y, because I said so. Y is less than 2. So we take 2, put a little open dot circle in it, we graph everything to the left. We say y is less than 2. Every part of that solution set, except for 2, 2 is not included, but everything to the left of 2 is included. I don't know if you guys can see my mouse moving, but I'll use my highlighter as a pointer since I'm not sure if you can see my mouse cursor when these things record. So it says you can check by substituting 0. Does 0 work? Yes, 0 works because 0 is part of the solution set. Could y be 0? Yes, y could be 0. Y could be any negative number. Y could be 0, y could be 1, y could be 1.999, but it cannot be 2 because that is not part of the solution set. All right, bingo, bango, bongo. So far, every part of this has been just like doing algebra, with the exception of you don't have one answer to solve y. We don't know one solution for y. We have to graph a solution set. So when we graph a solution set, we're saying y can be any of these numbers that we want it, but we don't know what exactly it is. So, for example, if I say that Lambeau Field can comfortably seat 58,000 fans, how many people showed up to the Packer game? You know, you're not sure exactly how many, but you know it's something less than 58,000. It's also not going to be negative because the last time negative people showed up to a Packer game, it just got weird, and so they don't let that happen anymore. So it's going to be some non-negative number of people that show up to a football game. Could be 0. Could be 58,000, but it cannot be 58,001. That number of people is not allowed in the stadium, right? Right, okay. So, I'm going to skip all the rest of this stuff. It's basically, you basically solve inequalities. So far, we solve them the same way that we do equations. You do the same thing to both sides. You get the variable all by itself on one side of the inequality. You have the inequality sign, and then you have some kind of a number. Let's say 9. You have some kind of a number. So we want one variable on the left with it. It could theoretically put the variable on either side, but on one side of the inequality, we have a variable with a coefficient of 1, positive 1. And on the other side, we only have a numeric term. Done. Let's pause the video. Let's do guided practice. Number 1. I want you all to do this. All 7 or more of you, however many 7th graders are watching me right now. I want you all to do guided practice number 1 on page 224. Let me make sure we're there. Page 224. Guided practice 1. Pause the video and do it. When you're done doing it, unpause the video. Hope you all did it and have an answer, because here we go. So it says, and if you're like, wait, what are we doing? The answer is we're doing guided practice number 1. Pause the video and do it. All right. What they give us is 0.2 x plus 3 plus 0.8x is less than or equal to 4. Sloppy, sloppy, I know. We can combine these terms right here. We can combine this, and we end up with x. So I'm going to do that. I'm going to combine x to both sides. 2/10 of an x plus 8/10 of an x is just x. So we're left with x plus 3 is still less than or equal to 4. We can subtract 3 from both sides. And if we do that, we're going to be doing, it's going to end up with, you know what else I can do? I can move my screen. Let me see if I remember how to do that. It's been so long. Ha 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 ha. All right. So we're going to do that. We're going to go with, how do I do this? All right. We're going to go with, so we're subtracting 3 from both sides. Sorry, this took me a longer than I was expecting. And we're going to end up with x is less than or equal to 1. So we're going to graph that with a filled in dot. The dot doesn't want to fill in very well. Less than, so anything less than or equal to 1, and then we're going to graph it that way. So it could be 1, or it could be anything less than 1, but it can't be anything greater than 1. So that's our solution set. Cool? If you didn't get your answer to look like this, where x is less than or equal to 1, then let's practice number 2. Otherwise, you can kind of skip ahead a little bit if you're, I don't know. I don't want to give you too much freedom. I hate freedom. If anyone knows anything about me, it's that I really hate freedom. I mean, I like my own freedom. I just don't like your freedom, if that makes sense. All right, guided practice number 2. Pause the video and try it. I'm going to put the big thing up. Pause the video. Try guided practice number 2. Okay, great. You paused it and you unpaused it. Here we go. We're going to end up, here's the solution, 1/4 x minus 1 plus 3/4 x is something greater than 0. Sweet. All right, once again, simple. We should be able to see that a positive 1/4 x and a positive 3/4 x, if I have those, that much of an x, then that means I have exactly 1 x. So if I have x and I take away 1, my answer is going to be something greater than 0. I can add 1 to both sides. Make sure you are adding 1 to both sides because we have a negative 1 over here. So in order to get rid of negative 1, I add positive 1, and I do the same thing to both sides. Let's draw it like this. Plus 1. I'm adding the same thing to both sides of my inequality. It's not an equation, it's an inequality. Words matter. I know some of you were thinking equation. So we're going to end up with the variable on one side and a number on the other. The answer is x is greater than 1. And we have to graph the solution set because I said so, because the book said so, because it's just true and proper to do, at least in this way. 1. So let's draw our number line. We're going to put 0 right here. We're going to put 1 right here. And x is greater than 1. It could not equal 1. It must be greater than 1, so we should have an open circle. If you don't have an open circle, consider your answer to be wrong. X is greater than 1. Man, they really like those 1s in these equations and inequalities, don't they? X always seems to be 1, or greater than 1, or less than or equal to 1. Sweet. All right. Hopefully you're tracking so far. This should be very review. Don't worry, it will get harder. All right, we're on page 225 now. I know what you're thinking. You're like, oh good, it will get harder. That's exactly what I was thinking too. All right, we're not doing guided practice anymore. Go away, you. Righty-ho then. So example number 9. Solve and graph a solution sets of algebraic inequalities with variables on both sides using addition and subtraction. Same kind of stuff. Let's see. They're like, I don't know if I even want to do this. I'm thinking about it. Okay, so read what enthusiastic math student says about it. He says, remember to check your solution set. You can substitute any value into the solution set and see if it works. So if you graph your little number line, See if your graph makes sense. It helps to check to make sure if your graph is pointed in the right direction. So if you get something like x is less than or equal to 19, like they show on page 225, and you graph your arrow, make sure pick a number that's less than or equal to 19. Pick, I don't know, 15, and make sure 15 overlaps on your arrow. All right, that's good advice. We're going to turn the page. Let's try guided practice number 2. Ready, set? Oh, not 2. What am I saying? It's 3. We'll just make that into a 3. Haha. All right, pause the video and do it. There we go. This is guided practice number 3. I'm always tempted to type the number 3 instead of drawing it on my whiteboard, but here we go. Guided practice number 3. We're going to do it. The answer should be x is less than 10. I'm going to skip to the answer and then we'll solve it. So you'll have, let's say, 9, 10, 11. X is going to be less than 10. Your graph should look like this on your scratch paper, which I know everyone is doing. You're not cheating. You're not just watching me do it. You're not waiting for me to show you the answer. You are doing it and solving it actively so you can learn for your own benefit. I just know it. 100% all of you are. X is less than 10. It's your answer. How did we get there? I'm glad you asked. Thank you for asking. 2x plus 3. This is what they gave us. 2x plus 3 is less than 13 plus x. Ha 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 ha. Now we have variables on both sides. So let's subtract. I'm going to subtract x from both sides. You could have done it differently and still come up with the correct answer. Subtracting x from both sides will get me x plus 3 is less than 13. I've succeeded in getting only numbers on the right side of this inequality. Now I'm going to subtract 3 from both sides. Minus 3, and lo and behold, I end up with this. X is less than 10. Whoop, and I graphed it underneath. Got it? Oh, okay, I'll do one more. Let's do number 5, fractions and whatnot. Go ahead, pause the video. Wah! Smiley face. Pause the video, then unpause the video. Good job, thank you for unpausing the video. Whoa. Whoa, all right, my computer got really trippy. I hope the recording didn't get messed up. Erase, don't erase my work, erase the board. Don't erase my recording that I made so far. It's good. Guided practice number 5, here we go. So if you get the right answer, you can feel free to skip the explanation or fast forward a little bit through it. But the answer is, if this is -4, and this is -3, and this is -5, you're gonna have a hollow circle here, you're gonna have it pointing that way, because x is indeed less than 4. How do we know that? I'm glad you asked again. What they gave us was, to start, we have 4 plus 1/3 times x, or 1/3 of an x, is greater than +8 and +4/3 x. Yeah, ha ha ha. So how can this be? How can this be? Looking at this problem, I'm left wondering, like, how in the world can you have over on one side 4 and a +1/3 x be greater than 8 and 4/3 x? Intuitively, this shouldn't make sense, right? Because over here I have 4. 4 is less than 8. And over here I have +1/3. +1/3 must be less than 4/3 x, right? And yet it says greater than. This is blowing my mind. Do you see? If you don't see it yet, if you don't see why I'm so confused, or pretending to be confused, ponder this. How can 4 and 1/3 of an x be greater than 8 4/3 of an x? Impossible, you say. Impossible. Well, prepare to be amazed. Okay, let's undo all that highlight jazz I just did. And let's get to the bottom of this, shall we? We're just going to do this the same way we've been doing algebra this whole time. We're going to do the same thing to both sides. So I like putting the numbers on the right and the algebraic variables on the left. So let's do that. So let's subtract 4 from both sides. So we're going to end up with 1/3 of x is greater than 4 plus 4/3 x. Okay? Now let's subtract 4/3 x from both sides. Or, that's really the only way we can do this, isn't it? I think I painted myself into a corner. Let's back up a second. I don't want to introduce this just yet. I'm going to back up a second. I know I'm going off script here a little bit. Let's instead, I don't want to spoil the surprise here. I could solve it that way, but I'm going to solve it this way instead. Let's subtract 1/3 x from each side first. 1/3 x minus 1/3 x. We're going to get 4 on this side. We're going to say 4 is greater than 8 plus x. You see what happens when I take away 1/3 x from 4/3 x is I get 3/3 x, which is the same as x. So 4 is greater than 8 plus x. Now, we can just kind of intuitively look and see, well, how can this be? X must be something it should be a -4. My bad. X is less than -4. X would have to be less than -4. So if x was -5, this would work, right? -5 plus 8 would be 3. 4 is definitely greater than 3. But let's keep going. Let's subtract 8 from both sides. If we subtract 8 from both sides, then I'm going to get -4 is greater than x, which, look at the solution here. See how I have it worded over here? X is greater than, or excuse me, x is less than -4. If -4 is greater than x, that means that the opposite, the converse, I shouldn't say opposite, the converse is true. X must be less than -4, right? 3 is less than 5. 5 is greater than 3. That's just always how that language works. So you look at it in a mirror, you'll see it separately, like that. And this should make sense, right? If 4 is greater than 8 plus x, then that means that -5 would work, because we would plug in, oh yes, sure, go away. If we pick 5 as a value of x and we plug in 5 right here, excuse me, -5, let me be straight. We plug in -5 right here, this works. -5 plus 8 would be 3. 3 is definitely less than 4. 4 is greater than 3. So I know I'm repeating myself. I apologize. I just want to make sure that we're really tracking. If you're not tracking, maybe pause it, maybe rewind it, maybe ask a co-teacher. However you can get it to where this is starting to make sense on a number line. Maybe if you got some manipulatives around and you're like, I need to see this. How is this possible? X, remember, any variable can be negative or positive. It can be negative or positive. So when I say positive x, I'm not saying necessarily that x is positive. I'm saying that it's x by itself, and x can be positive or negative. Okay. We're only 30 minutes in. Normally math class takes an hour. I left myself lots of time for this hands-on activity. Look at the hands-on activity. We're going to do it together. By the way, we're on page 226. So, sorry, I haven't updated the page number. We've been on page 226. So if you're like, where is this guided practice? It's on 226. I can do better than that. In fact, I can even do better than that still. Oh, sure, be that way. $226. All right, I'll move the whole board. There we go. All right, so use a copy of this table, and we're not going to do that. We're just going to do it on the screen here. So get your scratch paper. We're going to do it. We are going to set two values near each other or something like that. So let's start with yes, whatever. Come on. 16 and 8. Which one is greater? Which one is farther to the right on the number line? It's 16. 16 is greater than 8, which also means that 8 is less than 16 if you read it backwards. If you read it from 8 and go to the left, you'll have 8 is less than 16. Let's divide both of these by -2. Go ahead and take 16 divided by -2, divide by -2. What happens when we divide or multiply by a negative? It changes the sign, right? We flip the page in our book. It goes to the opposite end. So we're going to have, when you take -16 divided by, positive 16 divided by -2, you get -8. When you take 8, positive 8 divided by -2, you end up with -4. We did the same thing to both sides, didn't we? We did the same thing to both sides. However, what happened to this? Which number is greater? Remember the number line. It's not this. It's not that. -8 is not greater than -4, because which one is farther to the right on the number line? See these negatives? They just mess everything up. Our whole category has just changed. So over here we have 16, positive. Over here we have 8. And over here we have 0. I don't know if I left myself enough space to be according to... Oh, it's so tricky without finger tipping. All right. Messy number line, that's okay. Over here we have -8. And over here we're going to have -16. Got it? You tracking with me? So 16 is definitely greater than 8. It's farther to the right on the number line. However, between -8, oh, and I guess we have -4, and -4, which one is greater? -4 is greater. Wait a second. Compare. Compare and contrast. When we did the same thing to both sides, our inequality did not stay the same. The numbers both transformed, but what happened? The inequality sign must change directions. When we multiply or divide by a negative, the inequality sign changes directions because -4 is greater than -8. Now let's divide by, now the hands-on activity says to divide by +2. All right, so let's go ahead and just keep tracking. So now we're going to divide by +2, do the same thing to both sides, divide by 2. What do we get? We get -4 and we get -2. So we don't switch the signs because we divided by something positive. So it doesn't not change the sign of our divisor. I guess our numerator or whatever we want to call that thing, our quotient is still negative. We divided by a positive, it doesn't change the sign. Our quotient is -4, our quotient over here is -2. Which one is greater? -2 is greater than -4. So -2 is greater than -4. The sign does not change. We divide or multiply by a positive, it does not change the sign. That's basically the gist of it. They have you continue to go through and divide by. I guess I didn't technically follow it exactly, but anytime you divide by a negative, you must, or multiply by a negative, because it changes the signs, it changes these signs, it changes your positive negative sign, it also changes your inequality sign. It points to the other direction, because if we're flipping the page, the whole thing is backwards. You remember the exercise where we flipped the page? You had your notebook. You flip the page, you're going all the way to the other side. No, I said highlighter. You go all the way to the other side. You flip the page. It flips the whole direction on everything. Play with it around if you're so inclined. So what does this mean for algebra? What does this mean for the algebraic stuff that we're doing? Well, what it means is if we have something like, let's say -2x is greater than 4. We have -2x is greater than 4. We want to get x is greater than, and we want to do that. All right. So we want to get x by itself with a coefficient of +1, and we want to get a number on the other side. So we're smart. We know that we have to divide by this. As soon as we get it down to this step, we always divide by the coefficient. So -2x divided by -2. We do the same thing to both sides. What are we going to get? We're going to get x. Since we divided by -2, we're going to be left with just straight x. X with a coefficient of +1. And over on this side of our inequality, we're going to get -2. We divided 4 by -2. Our answer is negative, I think I forgot the negative sign over there. Our answer is going to be -2. But we must not leave the inequality sign like that, because not only do the signs change, the direction of the inequality changes. So whereas we have over here -2x being greater than 4, positive x has to be less than -2. If you don't believe me, pick a number. Pick a number to be x. Let's say x is 1. If x is +1, then does is -2x greater than 4? Think about it. Pause the video. My question is, if x was 1, I'm going to go ahead and just graph this solution set. So for this solution set, I say x is less than -2. We'll put -3 on this graph too. So think about it. If 2x is greater than 4, or excuse me, -2x is greater than 4, if x was 0, is 0 greater than 4? No. Okay, obviously. Is -1, what's -1 times -2? +2. Is +2 greater than 4? It is not. What about -3? -3 times -2 equals +6. Is +6 greater than 4? It is. Which means the solution set is correct, that x has to be less than -2. Well guys, I'm going to call it done for today. You have 20 minutes shorter on your math class because I didn't have so many interruptions to deal with. But I also didn't get to answer questions. If I've made a mistake, if I misspoke, if you think something was confusing, send me a student square message. Yeah, this is the thing that's going to blow your mind right here. right? That the inequality changes signs. But remember, you can always go back and check your work. You can always go back and see if I plug in these values up here, does my answer still make sense? So hopefully you're tracking. Hopefully you guys will get some good fun in that snow. I hope that happens. I pray the best snow day for you guys, and I'll see you next time. All right, peace out.